Hey everyone, welcome to today's webinar in which we'll discuss structured and unstructured data, tapping into their potential to drive your research forward and how to leverage the power of AI in converting between these data formats. We're very happy that you've decided to join us today. Let me dive right in and introduce our panelist. So we have Eleanor Dixon-Broch, product manager at Research Solutions, join us today. And then also myself, Julia Heeson. I'm a senior growth marketing manager at Research Solutions, and I'll be your moderator for today's webinar. Quick housekeeping items. We will record this, so you don't have to worry about if there's any specific part that you want to rewatch or you want to share this webinar with a colleague later. You don't have to worry about any of that. I'll send out the recording probably about an hour after the webinar. In case you don't receive it, of course, you can let me know or send me an email. Other than that, we have live Q&A enabled. So we have dedicated time. If you are on the Zoom bar below where it says Q&A, you can add your questions as they come up, or if you have questions already, feel free to add those. But we'll come to all of your questions toward the end of the webinar. But know that we're not forgetting about your questions. We do have that dedicated time. Awesome. Well, with that being said, for the ones of you that aren't familiar with Research Solutions, let me give you a brief introduction. So Research Solutions was founded in 2006, and we simplify and streamline how organizations discover, acquire, and manage scientific articles and data. With a suite of innovative products, we empower researchers worldwide and in the way they transform the way scientific information is accessed and utilized. Also, a few months ago, we acquired Resolute AI, an advanced search platform aimed at equipping organizations with search, discovery, analysis, and knowledge management tools powered by AI and NLP technologies. And today's webinar will focus on some of the core abilities of these newly acquired AI technologies. And with that being said, I'll hand it over to Eleanor, and she'll be able to dive right in.
Thank you. So this webinar, we're going to be focusing on the differences of structured and unstructured data, and also being able to switch between the two when you can, when it gets a little complicated, and that type of thing. So from like high level, a lot of there's information overload in general. Just there's a lot more data that's being created. If we think even just terms of publications, internal data, like more and more and more gets created. Also, with the age of technology, it's easier to store this data forever and then come back to it years down the line. So just before we go into that, just from a high level, the type of products that are available and how they kind of all work together from Reprints Desk, Resolute, and now Scite. So from a discovery point of view, Scite is very much focused on publications. Foundation is part of the Resolute family, and that's looking at lots of different types of data sets. So patents, clinical trials, grants, and many more. Then we have like an analyze section where it's guiding you through a workflow. So you actually go through a bit of a discovery process, and at the end of it, you get a report. Then there's access, so document delivery through Reprints Desk, and then management, which is references. So I'm going to do a brief demo of Resolute Foundation specifically, which is looking at external data sets and having understand maybe a little bit of an intro into data in all kinds of different formats. So we have lots of different data sets, like I mentioned, and we have a federated search, which means that if you do a single search, it's going to be applied to all of the different data sets. So I'm going to do bone regeneration, and I'm going to make it proximity phrase, search, and now it's searched across all of the different data sets. So Nebula, that's looking at the concept of internal data. So basically a bunch of PDFs that were created internally about lots of different things. And then there's Foundation, that's focusing on the external data sets. So a variety of data sources we either license or we scrape or for APIs, etc. We're mostly focused in the research area of companies, especially like life sciences. So we have some FDA data sets and then publications, for example. So I'm just going to go over to publications. So now I'm going to search view, and this is where you can kind of get a little bit more tailored in what you're doing. So on the left-hand side, there's a whole bunch of filters. And this is all of the metadata, and we're going to get into more about what metadata is. For some people, it's going to be your daily job. For other people, it's that word that keeps coming up that doesn't have a whole lot of meaning. But essentially, the idea is like you have a record and you have some values that are attributed to it, and then you can add some more values on top of that that will make it easier to search and find and analyze information. So we have all these different ways to apply filtering. We have our own proprietary tagging systems through using different ontologies. And then we also run everything through processes. So we're up here where it says tags. That means that all the information that comes in, doesn't matter the source, it's all going to get processed. And if it is relevant to certain words, it gets that extra word added onto it. Now it has that metadata. So if I apply the filter, now I'm going to start looking only at anything that's bone regeneration with the tag osteoblast. There are lots of other capabilities. So heat maps is a really popular one that we have because it gives you a really good overview of a ton of data. So we have like 8,000 odd results. That's a lot of information to get through if you're just trying to get a high level overview. So I could look at, for example, let's say the author affiliation. So I want to know like who's publishing what, where, get a sense of maybe those authors, and then the dates. So this is all different ways to look at data. Now I can get a sense of, this person at this particular university, they tend to be publishing a lot in this area, and they're increasing their publishing rate. So it's a really quick demo, but just give you a sense of the kind of stuff that we do. So I'm going to go into the demo, Julia, if that's the rest of the webinar.
Awesome. Yeah. And of course, just as a reminder, everyone, if you have any questions or, there's something you just saw that you want us to, get back to, you have a question about that, feel free to add that to the live Q&A, and then we'd be happy to get back to that. Okay, now back to you, Eleanor.
That's good. Okay, so we're going to start from the baseline, which I'm sure most people here, they know what the data is, they know the data that they use every day, but I want to make sure we all start from ground, on the ground zero altogether. So there's different ways of categorizing data, and it's important to really think and be conscientious about how this data is being categorized, because it's going to define what you can do with that type of data. So title of this webinar is structured and unstructured. Those are two different ways to categorize data. Structured is, if you look on the right side, there's a table. It's got numbers, and then it's got the description of what those numbers would mean. So right here where it says trial number 1, and then the salt concentration is at 0%. So the 77.23 is associated with the first trial, and salt concentration at 0. This is very structured. There are rows, there are columns, and exactly, you can do comparisons. So this is the whole thing, this trial number 1, trial number 2, at the same concentration, I can very easily see the differences in outcomes. Unstructured data is this section right at the bottom where there's just a paragraph of text. So there's a bunch of people on this webinar, and if I asked everyone here to take notes on anything that I was talking about, everyone's notes would look completely different, even though it's really about the same thing. You could just be writing bullet points. Some might be writing prose. Some people might be writing little boxes with words in it and then an arrow. So now you have an image as well. And this is where it can get really interesting, because you can get a lot more insight and context, but it's a lot harder to do true comparative analysis. Another way to think about data is the difference between quantitative and qualitative. It's a very simple difference, but it's an important difference to remember. So quantitative, anything that you can measure. Qualitative is a description. This type of data comes up all the time in many different industries, and it's the type of data that everyone uses pretty much every day. So whether you are looking just in your customer relationship management, CRM systems, that's a combination of different types of data. Everyone uses both types all the time. So we're going to dive into structured data a little bit. So on the right-hand side, it's a massive image, and you can see where it has in pink, there are some words, and then in green, there are some words, and in some cases, numbers. So like I mentioned on the previous slide, structured data is that there is a set place for that data to go. And it's usually very limited in the format or like the option of the type of data that gets put into that. So if we think in this case, like this is a bunch, like a grouping of data. And we know, for example, so patient ID, like this is going to be this type of data. We can only put ID types in here. And so there's going to be a rule that it's, in this case, let's say it's only numbers. So you can only use the numbers. In name, this is text. Name gets a little bit interesting because obviously names, there are lots of different type of names. But say diagnosis and medications. On the right-hand side, there are some examples, but this is, for example, like electronic health records like EHRs, or anything in the medical industry. There are different taxonomies and ontologies, so lots of different words, but there is a set number of words that you can choose from, and they're essentially the descriptions. So you can't just type in anything that you want. So if I wanted to type in sky for diagnoses, that's not a diagnosis, therefore it cannot work in this like particular structure. It has to be one of the predefined ideas. And so there's lots of different areas where these type of very structured data like occurs. So when I mentioned like EHRs, clinical trial data has a mix, but there's a lot of very structured data in there as well. So think like patient populations, eligibility criteria. So whether it's like male, female, if they're children, if they're older, that type of age range. There's different strengths and limitations, obviously, to how you store the data. Strengths are you can do analysis. Analysis is really easy when you know exactly where the data is and how you can compare it to other data. Storing it is usually with like a massive underline and inverted commas around that, because there's a lot of caveats around that. Usually it's fairly easy to store. So think even your Excel spreadsheets, that is structured data and you're storing it in a spreadsheet. When you get much, much bigger databases, maybe it's like a SQL database or SQL, they can get really, really big, and then storing it can get a little complicated depending on how big those data sets can be. So some of the limitations of structured data is especially like rigidity. So you have a very set format of how you're going to be saving this data. Deviating from that is going to mess with all of the other inputs that are already in there. So when you make a change, so the word schema, for some people, again, this is what you deal with every single day. Other people, schema doesn't really mean much. Schema is just the way that the data has to be laid out from a very like high level. So it's got to follow a certain type of hierarchy, and it's going to have certain type of rules applied to the values. You can only do so much with that, but the benefits of this really is the analysis. So if you're doing very strict analysis of like what is greater, what is smaller, where trends, this is really where this type of structuring is good. So I touched upon, scalability. So scalability, if you're getting really, really big, so you're usually going to have to take into account of like maybe some different ways to store it or cost and that type of thing. But the data silos are really very, very, very common for a number of reasons. It can be like someone didn't know that this data already existed, and then they have to save it somewhere else. It can be that there's different systems in place. It's really hard to kind of save it together. And over time, you just get more and more different data sets. And if you want to create connections between those data sets, that's another layer of work, and sometimes it's easier than others. But if you're trying to get the big picture, it can be really difficult if they're not structured in a logical way. So moving on to unstructured data. Unstructured data is basically everything else from a really like blanket overview. So if you have a PDF that has a report, that is unstructured data. It's got prose in it. It's probably got a mixture of some structured data in there, like tables. But the PDF itself is like one whole document. So that's the unstructured piece. And then you also have images. Again, those images could be embedded in something else. There's not inherent structure to that. This webinar is being recorded, and there is a PowerPoint being shared. I'm speaking, so that's also audio that's being involved. And then there's images of Julia and myself. So there's a lot of things that are going on in one space, and it can be a lot to try to analyze. And if you're trying to compare, say, like 5 different webinars together, you can't really do that very quickly just by looking at the raw data. You would have to watch and read all the different webinars to get an overview to do a comparison. So in order to do analysis on unstructured data, it has to go through different types of processes. And this is usually where most organizations, the data scientists, data engineers get involved, and they have to run whatever documents or data that you want to get insights out of, and they have to run them through different types of models. Basically, they're trying to figure out what patterns already exist and can we make sense of those patterns and then structure it in a different way. Or can we get like lots of significant words out of these documents and then start to only look at those words? So instead of looking at, 10 pages, maybe we're only looking at 10 words. The strengths of unstructured data is the insights, it's the context, it's the meaning around it. Like, this is not lost. When you're looking at very limited structured data and you only have like a few fields, like a few values that you can put into that, you lose a lot of that context. And this is really important is I think I had a more example before, but on this page for 510K summaries, so this is for medical devices when they want to bring them to market and they want to base it on a previous medical device. They have to include a lot of descriptive information. It can't just be this medical device pretty similar to this one, and that's it. There has to be, it is similar in this way, and give a lot of context around it. So there are true values to having unstructured data. It can't always make everything completely structured. The limitations may be pretty self-evident. Gets pretty complicated when you have a lot of long text and a lot of data that you have to comb through. Organization. Most people would love if all of their company's data was perfectly organized and all the folders were named exactly what they're supposed to be named. It seems really logical. Never have to ask anyone where anything is, and you can always find what you're looking for. That is almost never the case. And for those that have that, I'm so happy for you. So it's like just not usually what most people get accustomed to. It gets more and more complicated the bigger a company is. Really small companies can generate a lot of data, but when you have companies that have like thousands and thousands of employees, and now you have not just like 5 or 10 departments, like you can have hundreds of departments and sub-departments, and then you have permissions on like who can access said data and who can't. It gets really complicated, and it can be hard to find any of this data. So then you're relying truly on search. Like you have to input what you're looking for, and then you have to hope that you can find it. And if you can't, most people are going to go to someone that they knew worked on the project, or work with someone that worked with someone that worked with someone on that project, and that's how they can find it. So that's the data retrieval piece as well. Data quality, this is really important. So like you get greater context, but noise is automatically going to be generated, because if you're not being really specific in the words you're using, and you're just using words that would make the whatever language you're writing in, you know, prose, you just generate more words than are really needed to get good good information out of it. And so trying to sort through all of that, it can be expensive, it can be time consuming, it can generate some problems. So at the bottom, I just have a list of like less sort of examples, because most people will think of like their reports or maybe PowerPoints and those type of things. But things like emails right at the bottom. I'm just going to go through the last two or three, because those come up a lot just generally in people's daily lives. So emails, most people spend a lot of time writing emails, and in those emails can be really important information pertaining to your work. They can have the outcomes of experiments. They can have information about regulatory status change or any sort of prioritization. Again, or having those emails organized really helps, but then it's kind of hard to keep track of all of that. Free-form surveys. So surveys can have a mixture, right, of structured and unstructured, but any survey where it has a question and then it just has like, write whatever you want, that's going to generate unstructured data. It's just going to generate whatever it gets typed in. It could be one word, it could be a whole paragraph, it could be a page. Customer reviews, very similar to the free-form surveys. It does matter like how you structure those. So that's important when thinking about when you're trying to create the data from the beginning. So before we move on to the next part, is if you're at the beginning of any type of experiment, data gathering project or anything, it's important to think about in the long term, what's going to have to be done with this data? Like if you're not here anymore and someone needs to make sense of it, how are they going to be able to process it, analyze it, and understand it? Can you have a mix of unstructured and structured? Does it need to be separated? Will it need to be together? If you're at the beginning, you're at the point of luxury where you can really think about the best way to go forward and hopefully make your life and everyone else's life much easier. If you're in the middle towards the end where you have the data, you don't have control how it's generated, it just is what it is. Then you have to get into like, okay, how am I going to extract what I want to extract? Before that, it's just understanding what do I need to understand and why, and how is that going to be used? Because you don't want to do more work than is necessary either, because when it gets to data extraction and analyzing it, get really into the weeds and really complicated with it, it could be overkill. Or it could be just what you need. So really understanding what you're going to do with that data and why is going to help. So converting data types. This comes up all the time. Like I just mentioned, like you're at the end of coming to the end of a project, or a project's already been done, you have all this data, but it's not really what you want, and you need to be able to make sense of it in a way that it does not lend itself to. So the first one we're going to go through is going from structured to unstructured. Generally, this is a lot easier than the reverse. So I have an example on the screen, something that we're in the process of releasing, but we have the structured data. Over you can see my mouse, but in the middle, there's a place with lots of boxes, and it says publications and patents. So that is structured data. There are fields. So I know who the author is. I know who the affiliations are. I know what type of tags there are, how many forward references, date, etc. So those are the fields. And then I have the values. So the actual date, the names of all of those things. And I have a set of these data points. So I have 20 publications and 7 patents. And This is specifically for a tech landscaping report, but it's the same for any report, any summary, any presentation. You take all the data points and you have to understand it, and then you have to create something that has insights, some sort of summarization, a different way to categorize the data without having to be as lengthy and as detailed as the original data itself. So instead of summarizing, say, like each publication, what I would really want to know is, do these 3 publications have something in common? Can the summary just have these 3 things in common explained, and then another bucket of 4 explained, etc.? So I can get a high level overview. There's different ways to do this. I'm hoping, or at least assuming, most people have had experience with, say, ChatGPT or Bard or any type of the public large language models that can take something and summarize it. You can, those LLMs can be written internally. You don't have to use, obviously, any of those. But the whole point is you give a system some data, and you have to write a prompt, i.e. instructions. You have to be very clear what you want at the end, because it could, unless you say to make inferences, you want to be very controlled in what the output is. And this is very important if you're creating something that is structured to unstructured. The clearer your instructions are for the output, the better the output is going to be. Because if you think about it, you're literally introducing noise into something where there was no noise. But ideally, that is going to help you understand this and communicate this to other people faster. So instead of sending 25, 30, 100 documents to someone and be like, read through these, I found these helpful and they help me understand X better, write a 3-page summary, and most people do. So for structured to unstructured, there's lots of different ways to do that. Converting unstructured to structured is more complicated, more expensive, more time-consuming. And it matters greatly where you're getting that data from and its format. What I mean by that is, say you have a set of 100 PDFs, and all of those PDFs are formatted exactly the same. They have the title in the same location, they have the date in the same location, they have the author name in the same location. Everything is exactly the same formatted. If a human could look at it and they looked at these 100 documents and be like, yeah, these all follow the same pattern, then they can write a program that will recognize those patterns and like pass out those chunks. They will pull out the different chunks. It's like, here is it, make the title go here, make the author name go here, make the description go here, and then you have something that is now structured. If you have 100 PDFs and they all have different ways of being formatted, the title is in a different location, the date is in a different location, the name, everything is different, there is no pattern, there is no way to figure out without a lot of work. And even then, it's not going to be completely accurate. So the point where I'm getting to is, in some cases, it makes sense. It's actually can be quite straightforward thing to do. You can take different types of forms, especially forms where they are exactly the same. If you just think about, tax returns, those are very, very structured. You know exactly where you're going to put your name, you know exactly where you're going to put all of your information, and they are exactly the same. That's pretty easy to pass out and make into a very structured format. If you have, say, experiments in a notebook, and everyone writes this notes up differently. Like they just have a blank page and they just have to take notes on their experiments. And their tables can look completely different. Like sometimes their tables have like a nice, they put in all the lines, they put in all the fields, they have like very clear defined structure. Other times people will literally just write like the headings, some numbers underneath, and that's it. That's their table, quote unquote. It's very hard to understand which one's a table and which one's not. And if they all have different structures, it's hard to recognize a pattern. In those instances, it's easier to do it manually. So one of the examples that we have where we do this is for our tech transfer opportunity database. We scrape like 350 odd university websites, and we look through and decide, decipher where the title is and where the description is and where the inventor names are. Each website, all of their postings are the same format. The different universities have different formats. So for each university, we at least know the format, and then we can create the structured data from that. And that's what you're seeing on the screen. So in the middle where it says Toledo, that's from the website. That's what it looks like. And on the left-hand side, like the big image, that's the image of what it looks like in Foundation. So you can see like title goes where the title goes. There's a description where it goes. And then, okay, behind where the website is, that's where the inventor is, the date, and so forth. So basically, what I was just saying is, depending on how you want to get insights out of your data, you have to think about what you really want out of it and prioritize time, resources, money, etc. So just a quick reminder of like where structured and unstructured data come together. So with data diversity, there's lots of different types of data. Medical imaging, that is data. Like I mentioned, electronic health records, that's data. Emails that you write every day, that is data. It is all something that you can get insights out of, analyze, or do something with. So I'm not going to go through all of these, but the point is that there are lots of different areas where different types of data will come together, and you're going to have to figure out what you want to get from each piece of groups of data, and then how to analyze it. One thing to note with the unstructured data, I mentioned right at the beginning, but I'm going to repeat it just as a reminder. To make the unstructured analyzable and findable, let me go back for a second. All of this can go through a system, and you can add metadata on it. So when I was giving the demo, lots of people will do this type of thing where you have information, you put it through a process, and you add metadata on top of it. The metadata is just the concept of adding more fields with values to that, and that gives structure to something that is unstructured. So this description, for example, this is just like a whole bunch of text, that's unstructured. That will go through a system that will then figure out, okay, these words are significant, I'm going to add metadata onto it. Now you have something that you can actually analyze, because you could look at lots of different documents that have this metadata and then see what has more notes, etc. about that. Again, I'm not going to go through all the different types of data hygiene. You'll have access to this webinar later, but like mentioning before, if you are at the beginning of a process, you have the luxury to really think about how you want to go about dealing with your data, storing your data, what you're going to get out of it, how people might analyze it. It is worth noting, for example, so accessibility and backup and disaster recovery, those are the two ones I just want to spend a second on. Accessibility is really important. Can be thought of in many different ways. So just generally, even 508 compliance. So just like anyone can access your data, no matter what their abilities are to be able to access it. Descriptions on text are also descriptions on images. So the alternative text, the alt text, that stuff is really helpful for also not anyone that has visual impairment that could not even see the image, so that they can read the descriptions and understand. But now you also have metadata. You can now also search on that metadata to be able to search the images. Thinking about how someone's going to find your data is super important. Backup and disaster recovery. This is usually taken care of by someone in IT, but it is worth always involving them in the beginning, during the process, at the end, having them on board to understand, if things go wrong and things get lost, how are you going to get it back? And what are the implications if you do lose it? understanding that and across the board means that everyone's on the same page, makes relationships a lot easier. So I think we've reached the end of at least my description of unstructured and unstructured data. So
Yeah, thank you so much. That was such an interesting overview of structured and unstructured data. We've received a few questions already. If you haven't added yours, feel free to add that right now. I just have two more quick call outs and then we'll get to your questions. So we organized quite a lot of webinars here at Research Solutions, and one that I specifically want to call out is the one you see right in the middle, key insights within minutes, because we're about to launch a technology landscape module, and Eleanor, being the product owner of that soon to be launched product, could you give us like a brief overview of what that is about and why people should sign up to the webinar? That link I'm adding in the comment right now, by the way.
yeah, for sure. So an example of going from structured to unstructured. We started with technology landscapes because we have a lot of people that currently do them, and it's something that most companies either do in-house or they have to outsource. And so we've created a way where you can coalesce a whole bunch of data through a workflow, and then it will generate a editable tech landscape report with all of the references.
Amazing. Yeah, so links in the comments if you want to sign up. I'd love to see you there. Okay, and then just the next call out here, I'm adding another link. If you like what you heard today and you want to learn more about either Foundation or be one of the first to access the technology landscape reports, you could fill out the form under the link that I added, and then you can directly book a time. It'll route you to the right person to book a meeting with, and then we can dive deeper. You could get more in-depth demo or just like specifically to your needs. Invite your colleagues as well, so feel free to do that. Okay, now let's get started with questions. My always favorite part of each webinar, and if you watch a few of our webinars, I always say that. Okay, so first one here. How are language differences dealt with? For example, multinational companies.
Yes, great question. Okay, so depending on so whatever system that you're going to use, you can have those so this is going to get complicated because of large language models, but you can have language models and dictionaries and processes, and the concept of either translating or just being able to search on different languages. But that is it has to be something that is designed and consciously thought of. So it's not just a translation problem. It's a think about what languages you actually want to be able to translate for and search on. And that's kind of where you have to start. So if it's all languages, or if it's a company, say that you deal with like 5 languages primarily, so maybe you just want to focus on those 5 languages.
Awesome, thank you. Yeah, great question. If you have a follow-up question, feel free to add that here as well. Okay, the next question I see is, when is it worth developing a model to convert some PDF forms into a structured data set versus getting someone to do it manually?
Yes. It's usually how much time do you have? How many resources do you have? How much money do you have? And that's candidly because if you have, let's say, a whole bunch of, actually, like what I was mentioning before, like if you have a lot of PDFs or experiments that are in lots of different formats, you could spend a lot of time and money trying to develop a model to be able to put that into a structured way. That said, because it's not a guarantee that it's going to be a great output, you're then going to have a person anyway to go in and do like a quality check and make sure that everything is okay. If you have someone on staff and you can pay someone to just do it because it's going to be a lot quicker than writing a program, then it's worth it. If you have a data volume that's like enormous, like hundreds of thousands of long documents, yeah, then it's maybe not worth it. But if you have like, say, a few hundred, it might be overkill. So.
Awesome. Is there a free trial for Foundation?
Yes. I assume you can sign up somewhere for that.
Yes, that last link, everyone, that I sent in the chat, where it says /sales, if you fill out that form, there's a comment section. Feel free to add to that if you'd like to get access to your free trial, and we'd be very happy to give you access to that. Sometimes it's just nice to play around with the system yourself, or if you want, to jump on a call, get a bit further explanation how to actually use it, we'd be happy to do that as well. To create summaries from data, what are the best practices to keep in mind?
So one thing to be aware of is what's the data you're going to be inputting? Is it proprietary data? If it's proprietary data, don't want to be using something that is publicly created, or be very mindful of, like, you'll have to have probably your own instance. So you'll have to pay for that, obviously. You can write your own LLMs in-house as well, so you can process that if you're using, especially if you're using internal data. If you're using public external data that's already available to everyone, it depends on your practices, like within your company, like how comfortable they are with how you create your prompts. But most importantly, it's just thinking about the security and privacy of what you're asking and what you're trying to figure out and what you're actually trying to summarize. And then also, are you only taking into account the data that's being summarized, or is it going to the entire, if you're using one of the publicly available ones, like making sure it doesn't start hallucinating, which I'm sure most people are aware of, that they do a lot of, like, just only use the information that's being provided, like the references.
Amazing, thank you. Okay, so I see one last question here. If you have other questions that you just haven't added yet, feel free to do that right now. So the last question I see is, Eleanor, you mentioned the chaos of unstructured internal data. Is this something your product can help us with as well? Structuring my unstructured internal company data, for example, in our company SharePoint.
Yes, yes, we do that. So actually, right at the beginning, I'm not sure if everyone was, if you remember, but there's a product called Nebula. And that's actually exactly what happens there. We take everything that is in your SharePoint and we just put it through all those processes of adding the extra metadata, do transcriptions on it. We do optical character recognition. So we're looking for any handwritten text, transcribe video, audio, and then you can search on that. So then the folder structure becomes a lot less important. You can still see it. But yeah, now you can actually just search the entire contents of your SharePoint instead of just the titles, pretty much.
Great, yeah. And same for Nebula. Under that same last link in the comments, in the comments, you can fill out the form, and then of course feel free to ask us about Nebula as well, and we'd be happy to share more information with you. Awesome. Looks like we've answered all questions, everyone. Always nice to wrap up a little bit early. If any questions come up afterwards, you can always reach out to us via email. All those emails about the webinars that you received, those go to me, so I'd be happy to take those questions. Of course, you can also reach out via LinkedIn, or really whatever you prefer. We'd be happy to take questions offline as they come up. And well, thank you so much, everyone, for joining. Thank you so much, Elena, for giving us this great overview. And we hope to see you on that next webinar.
Thanks, everyone.
Goodbye.